On a quiet night, a radio telescope recorded something that should have been almost impossible to detect. It wasn't a nearby galaxy. It wasn't a familiar pulsar. It wasn't even coming from our corner of the universe. Instead, the signal had traveled nearly 8 billion light-years before finally reaching Earth. That meant it had begun its journey when the universe was almost half its current age. For billions of years, it crossed expanding space without disappearing, and somehow it was still strong enough for scientists to hear. The discovery immediately raised a question. What kind of cosmic object could produce a radio signal powerful enough to survive such an unbelievable journey? Astronomers knew they weren't listening to noise. They were listening to one of the most energetic events ever detected. The signal was captured by the giant meter-wave radio telescope in India, one of the world's most sensitive radio observatories. Researchers quickly realized it matched a very specific frequency known throughout astronomy: hydrogen, the simplest element in the universe. Normally, hydrogen emits radio waves at a wavelength of 21 centimeters. That signal has helped scientists map galaxies for decades. But this time, something was different. The radio wave had been stretched dramatically by the expansion of the universe. Instead of arriving at its original frequency, it reached Earth at a much lower one. The amount of stretching revealed an astonishing truth. The source wasn't millions of light-years, it was nearly 8 billion. That alone should have made the signal almost impossible to detect. Normally, emissions from such enormous distances become far too weak. They simply fade into the background. Yet this one remained surprisingly clear. Scientists checked the instruments, then they checked them again. Nothing was wrong. The signal was real. Now another mystery appeared. If ordinary hydrogen this far away is too faint to observe directly, why was this one visible at all? Some researchers initially suspected a rare cosmic coincidence. Maybe another object had somehow amplified the signal. Others wondered if a hidden process inside the distant galaxy had created an unusually bright emission. Neither explanation fully fit the data. The investigation became even stranger after astronomers examined images of the region. The source galaxy looked ordinary. It wasn't exploding, it wasn't colliding violently with another galaxy. It didn't appear exceptional enough to produce such an extraordinary observation. Yet the radio signal kept pointing back to it. Then an entirely different possibility emerged. Perhaps the galaxy itself wasn't responsible for the signal's remarkable brightness. Perhaps something between that galaxy and Earth had changed everything. This idea came from one of Einstein's greatest predictions. Gravity doesn't only pull on matter, it bends light, and radio waves behave the same way. If a massive galaxy lies almost perfectly between Earth and a much distant object, its gravity can act like a giant natural lens. Instead of blocking the distant signal, it magnifies it. The effect is called gravitational lensing. Astronomers have used it to observe galaxies that otherwise remain invisible. Could that explain this impossible detection? Researchers began studying the path of the radio waves in extraordinary detail. Every measurement suggested the signal had indeed passed through a cosmic magnifying glass. A massive foreground galaxy had bent space itself. As the radio waves traveled around it, they were focused towards Earth. The universe had accidentally built a telescope far larger than anything humans could ever construct. Suddenly, the impossible became possible. Without that invisible lens, the ancient hydrogen signal would never have been detected. But once scientists realized they were seeing ordinary hydrogen from almost 8 billion light-years ago, they understood they had accidentally opened a completely new window into the distant universe. And what that window revealed next could change how we study the history of galaxies forever. The moment researchers confirmed gravitational lensing, the discovery became far more than a record-breaking observation. It became a rare opportunity to look back into cosmic history. Because light doesn't travel instantly. Looking 8 billion light-years away means looking 8 billion years into the past. The galaxy that produced this hydrogen signal no longer exists exactly as we see it today. What astronomers detected was a snapshot from an ancient era preserved by the speed of light. That makes discoveries like this incredibly valuable. They allow scientists to study how galaxies behaved when the universe was much younger than it is now. And hydrogen is the perfect messenger. Long before stars and planets formed, hydrogen filled nearly all of space. Even today, enormous clouds of hydrogen serve as the raw material for future stars. By measuring hydrogen in distant galaxies, astronomers can estimate how much fuel those galaxies still had for creating new generations of stars. Until recently, making those measurements at such extreme distances was almost impossible. The signals were simply too faint. This discovery changed that. Thanks to nature's own gravitational lens, scientists were able to observe hydrogen farther away than ever before using this method. The discovery also confirmed something important. Large reservoirs of hydrogen were still present in galaxies when the universe was roughly half its current age. That tells researchers those galaxies still had plenty of material available for star formation. In other words, they were still actively building the universe we know today. But the investigation didn't stop there. Astronomers compared the distant galaxy with nearby galaxies observed in modern times. Despite the enormous gap in time, they found familiar patterns. Hydrogen still followed the same fundamental laws of physics. The universe had changed dramatically over billions of years, but its basic rules had not. Gravity behaved the same. Atoms behaved the same. The same physical laws operating in laboratories on Earth were already shaping galaxies billions of years ago. That consistency is one of astronomy's greatest discoveries. Every successful observation from the distant universe strengthens our confidence that the laws of nature are truly universal. Even so, many questions remain unanswered. How many more galaxies like this are waiting behind gravitational lenses? How much hidden hydrogen has escaped detection because no natural lens magnified it? Could thousands of ancient galaxies still be invisible to us simply because their signals are too weak? Future observatories may finally provide those answers. New instruments, including the Square Kilometre Array, are being designed to detect extremely faint radio emissions across vast regions of the sky. Instead of relying only on lucky alignments, astronomers hope these telescopes will directly observe hydrogen from even earlier periods of cosmic history. Each new detection will fill another missing chapter in the story of galaxy evolution. Together, they will reveal how ordinary clouds of hydrogen slowly transformed into stars, galaxies, planets, and eventually life itself. Perhaps that's the most remarkable part of this discovery. The signal wasn't a message sent intentionally across space. It wasn't evidence of alien technology. It wasn't a mysterious transmission aimed at Earth. It was something even more profound. A natural radio whisper from ordinary hydrogen. A whisper that began its journey nearly 8 billion years ago. It survived the expansion of the universe. It crossed unimaginable distances. Its path was bent by gravity exactly as Einstein predicted. And after billions of years, it reached a small planet orbiting an ordinary star, where curious minds had finally built instruments sensitive enough to hear it. Every extraordinary discovery in astronomy reminds us of the same truth. The universe is constantly speaking. Most of its signals are simply too faint, too distant, or too ancient for us to notice. But every time technology improves or nature lends us a gravitational lens, we hear another forgotten chapter of cosmic history. And somewhere beyond the edge of today's observations, countless more ancient radio whispers are still traveling through space, already on their way, waiting for the day humanity is finally ready to listen.